Hello, hello, hello. Scott, you there, my friend?
I am. I made it just in time.
Well, actually, technically, you're a couple minutes late, but I think we'll forgive you just this
All
week.
that time changing, right? We're the only country that did it. It's throwing everything off.
Last year, I had the pleasure to be in France for KubeCon EU. And so the Sunday that I left was daylight savings time and was in France for 2 weeks. First week was for the conference, and the second week was for vacation with my family. So we came back doing daylight savings time again. So that really was that was a rough day coming back. But how you doing, my friend?
I am good. How are you?
Good, good. And we got Jack. We got Jack here. So real
Yeah.
quick introductions. There's Jack from over from the CNCF Virtual Book Club, uh, that we were doing for a while. So real quick introductions. Hello, everybody. My name is Mark Borstein, CTO at Tremolo Security, co-author, Kubernetes and Enterprise Guide, 3rd edition. Scott.
And I'm Scott Strowich. I am a principal engineer for Kubernetes, Google Cloud, stuff like that for a tier 1 global bank. And
Awesome.
Hey, David from the UK.
Yeah. Say hello. Hey, David, all the way from the UK. Hopefully you'll be able to join everybody over at KubeCon in a few weeks. I'm a little bummed I'm not going to be able to make it this year. London is easily one of my favorite cities in the world. It's so strange to just be walking and be like, oh, hey, look, Tower of London, drawbridge, castle in the middle of a big metropolitan city. We just don't do that here in the U.S., which is sad sometimes because life might be better if we had more castles.
We're not old enough to have castles, though, right?
No, we're really not. I mean, we have castles. I mean, in New
We
England especially, we got a bunch of castles because there were a lot of really rich people who said, we want castles. So you go up to Gloucester, there's a castle. There's a few of them.
There's one in Albany, New York, too. That's a big one over here.
It's kind of crazy. So kind of an unimportant topic today. Authentication, right? Like this is kind of where we started. This is where we met. Was in authentication and getting people into the clusters. And this was the first chapter of the book that I wrote, and this is the first chapter of a book first thing that wasn't a blog post that I had ever written post education, right? So this chapter is kind of near and dear to my heart.
And I think, like as I posted, Mark, right? It's a great chapter. I always tell anybody, you want to get into the background on OAuth, you want to understand, refresh tokens, everything. I mean, these couple chapters, right? These kind of all. I don't want to say they do kind of link for at least the next couple. Well, actually, throughout the book at this point, right? Because we will have authentication. It's a big thing in there, and not just authentication. You got your I'm going to be on. I'm going to do this because so you don't have to. Hey, we got our Kafka.
Yeah, we got Kafka back. We're getting a regular show in here, Scott.
Always good.
Bonjour, my friend.
We appreciate that. Like I said, poor Jack there has known us for a long time now.
Yeah,
our extended virtual family from the book club, which is awesome. And because guys, everybody on the call, we love doing this. Mark and myself. Somebody says, "Hey, you want to talk about Kubernetes?" We're like, "Sure." Who?
Yeah,
Where?
Exactly. Give us time, place. We'll be there.
Yeah. So sorry, we're talking about this, and obviously integrating some of that authentication, right, with accessing backend systems like Kubernetes dashboard and that. So I'm really, I myself look forward to this discussion. I tell everybody I learn something new all the time, and undoubtedly even in this, I've done it a lot, read it, worked with you on this, right, Mark? But conversations will lead into something where I'm going to say, "Oh, cool, I didn't know that."
And the crazy thing about Kubernetes authentication is it's so deceptively difficult. Like it seems like such a simple thing, right? Like I'm going to authenticate. Give me something to authenticate. How do I identify myself? And it's one of those things. Like I've got a friend and customer as well that I would have conversations with him where he'd be like, we're just going to use this provider. We're just going to use that provider. We're just going to do this. We're going to do that. After about 6 months of, kind of going around the axle and finding a problem with every one of those providers, you'd find like, we're just going to use OpenID. And like, it's one of those things that it's so deceptively simple. And there are so many things that can go wrong that, you really have to have a really deep understanding as to what's going on to keep from exposing yourself. Perfect example. So I've been working with the Headlamp team. Headlamp is a GUI for Kubernetes. It was originally written by the same people who did Flatcar that got bought by Microsoft. And, they're integrating impersonation and token pass-through into the dashboard to make it easier to host, similar to the way the Kubernetes dashboard works. And we're going to talk a little bit about the Kubernetes dashboard today. We actually have an entire chapter devoted to it because of how important of a topic dashboards are in Kubernetes. And they said, okay, well, we're gonna make our dashboard token the one doing the impersonation. We're going to validate the token and then do the impersonation with our token. It's like, that's a terrible idea. And this is why. And they're just like, well, but this is what users want. They go, well, users don't want to have to authenticate anyway, right? Like they don't want to authenticate. What do users care? And so it's one of those things that it's important on the cluster owners to not just do things securely, but to do things securely in a way that's easy for users to use. Because if you make it hard for them to use, they're going to find ways around it that are easier for them.
And it only takes one to find it. Like I say, they're very entrepreneurial. They find out, they post it on Confluence somewhere. And then everybody
often with the key to go with it. So we got a lot of labs in this one. And the thing that I really liked about this chapter is we start off, and we're talking about chapter 6. So I know the title says chapter 5, but it is in fact chapter 6. We start off talking about the fact that Kubernetes is a little different from what most folks are used to when they're dealing with enterprise software. Like usually, you log in, you get you fire the thing up, you open a GUI, and you go look at your, you get that first username and password, right? It's either hard-coded or you're asked to make it or whatever. But Kubernetes is different in that, one, there is no built-in UI, right? Like it's just an API. That's it. And like we even quote this scene in from the Matrix when when Neo goes to go see the Oracle, and the little kid is bending the spoon with his mind, and he says the trick is to realize there is no spoon. Well, in Kubernetes there are no users, there are no groups, right? Except for ServiceAccount, which we'll talk about in a second, which is a little bit of a special snowflake. But there are no users in Kubernetes. There are no passwords. So what ultimately ends up happening is you start off with if you're on-prem, you get a master certificate. So this is a certificate that can do whatever you want. We'll talk about certificate authentication. And like that's good enough, right? And I gotta say it slowed down a little bit now that OIDC and impersonation have become much more the mainstream. But I got to tell you, for a few years, at least once a month, there was someone coming into the SIGAuth Slack channel for Kubernetes being like, so we accidentally gave somebody a certificate that we weren't supposed to, or we emailed it. Can we revoke it? And the answer is no.
Well, the answer is kind of yes. If you want to redo a lot of stuff.
If you want to rekey the entire cluster, because Kubernetes doesn't do certificate. And we'll talk about that in a second. So there's just so many different ways to authenticate. There's so many issues you run into. I've gotten into discussions with folks who are like, Kubernetes should just have users. Like this is all Kubernetes fault. They should just have users. Like, okay, how are you going to authenticate them? With the password? Where are you going to store the password? In etcd? How are you going to get them that password?
You can do, come on, you can do that, right?
Yeah. Okay, fine. Let's say for the sake of argument, that's a good idea. It's not, but let's say it is. right? How are you going to get them that password?
Yep.
Can't authenticate someone who hasn't authenticated yet. You're going to email it to them. So now Kubernetes needs an email system to start off, right? Like, people start thinking through this. It's like, oh, that's not very good. So going without users the way that they did, I think was an incredibly smart decision. That was the right decision. So I've got the chapter open here. And technical requirements, so you're going to need an Ubuntu 2204 VM. We've got one keyed up and ready to go. I think I recommended I think we did this for all of them these days, was 8 gig of RAM. Technically you could probably get away with 4 gig. But we recommend 8 gig.
In that, right? But that's just because of having more.
This lab we won't need it. Once we get to once we get to monitoring, I think that's the first one where we're like, you're going to need some horsepower for this thing because we're running OpenSearch. Excuse me. So, we start off in the chapter, and like we just said, that like there are no users in Kubernetes. There are service accounts. Service accounts are meant to identify workloads. They are not meant to identify external accounts, external users. So in the beginning, there was ACAP or not ABAC. Excuse me. There was ABAC, and that was the ability to use a hard token that was sitting in a CSV file, basically. And that was bad, right? Because you had to restart and the permissions were all hokey. So that eventually grew into, you had two options, right? You had certificates and you had bearer tokens. Now with certificates, what becomes important to understand is if you're in an environment where you might use certificates to authenticate the things, maybe your badge has a certificate on it. Pharma does it a lot. I know the U.S. federal government does it. I don't know if other federal governments do. Aerospace and defense does it a lot. You might think, well, I could just use that certificate. No, Kubernetes has its own built-in certificate authority. So every certificate, the only certificates Kubernetes will recognize are the ones that it has issued. You can't say, hey, go recognize these certificates, right? So even if you wanted to use that, you couldn't.
With some of this, right, Mark? And correct me if I'm wrong, this is still the case, a CRL, right?
Yeah, you can't do CRLs. So CRLs, it's a good point. Certificate revocation list. So certificates tend to be long-lived, and we'll show this off in a moment. When I'm getting notifications on LinkedIn, and okay, the reactions. I if you're on LinkedIn and you're saying anything to us, I don't think it comes through to us here in StreamYard, so I do apologize. So certificates tend to be long-lived, right? Like they tend to be at least 30 days, sometimes a year. And what ends up happening is those certs, if you don't want it to still be valid, how do you tell the certificate authority that, right? And, the authentication system that. And that's done through either something called a certificate revocation list, where it's just a big list. Like it's just exactly what that, we've revoked these certs. Or you use something called OCSP, which is a protocol, a client server protocol for checking if a certificate is still valid. And Kubernetes doesn't support those. It's been a known audit finding for like 4 years since they started doing security audits of Kubernetes. And it will probably never support it. A little bit of they don't want to, a little bit of technical challenges. There will never be certificate revocation in Kubernetes. So if you're using certificates for authentication, that's always going to be an audit finding. That's always going to be an issue for you. Then you get the bearer tokens, right? And bearer tokens are what you probably should be using for the most part, where you get a token, and that token should be short-lived, and you hand it off to the API server, and the API server has a way to validate it. And the key is that whenever you call a Kubernetes API, you have to assert everything about your identity. So not just who you are, but what groups you're a member of, at least if you're using OpenID Connect. Now, if you are doing a custom authentication, like the way the large hyperscale clouds do, then that's a little bit different. If you are not a hyperscale cloud, you should not be writing your own authentication. Writing your own authentication for Kubernetes or anything really is akin to writing your own encryption. You're going to do it wrong. Right? Like I haven't seen your code. It's wrong. You're not doing you're not doing enough negative testing. You're not doing enough, you don't have enough eyeballs on it. These protocols have gone through hundreds, if not thousands of hours of reviews over the years. You do not want to write your own authentication. So we don't even cover that in this chapter. Then we get into groups. And the thing about groups is just like users, they don't exist. Right? Like there is no group object in Kubernetes. Unless you're talking about OpenShift, that's a whole other animal. But groups do not exist. The only kind of caveat to that one is all service accounts are assigned to some system groups. But even then, that's automagic. Like there's not a group object that lists all those things.
To me, Mark, I call it almost like an alias to the user, right?
Yeah.
It really is. It's really, you're just getting another stamp. And
Yep.
It really isn't, give me all the people in this. No, there is no all these people. You got to say
Right.
who has stamps. So, yeah.
Exactly. So we've talked about that. So then we start getting into service accounts. Now, this is where people start getting into trouble. Because, look, you keep telling me there are no users, but now all I have to do is create the service account. And, pre-124, it just created this pretty little secret that never expired. So I'll just hand this off to someone and they can access the cluster that way. And
but yeah.
Yeah. And so there are a lot of problems with that. One, how secure is your movement of said secret? Two, the secret never expired unless you deleted it. So that means you either have to build a manual rotation system or something. And three, you can't do groups with service accounts. You can't go create a object that says this user is a member, this service account is a member of a group, which means now you have to enumerate all of your service accounts across RBAC bindings. And we talk about RBAC a little bit in this chapter, but really that'll be the next chapter we'll focus on. So those RBAC bindings can get really big and difficult to track. You're going to break if you're in an enterprise, you're going to break your compliance by using service account tokens. They were never. Yeah. No, go ahead, man.
So we talked about this, Marcus. So we had this conversation years ago, right? So what we saw a lot of people doing in the community industry, whatever, right, was cool. I'm going to do a CI/CD pipeline. How am I going to get that pipeline to connect? Well, I'm going to use a Kubernetes service account. That works. Don't get me wrong, right? But people then take that token and hand it off to everybody else.
Yep.
And now, how do I audit that? Okay, somebody might be thinking, look at the API server. You can figure out where the IP is coming from. Sure, absolutely. But it's so much easier to see S. Sarovich logged in, M. Bushkin logged in. Because you're not handing out your password to people. And if you are, well, you're probably not going to employ long.
Hopefully you're using MFA. But that's a whole other
conversation. That's a different conversation. But yeah, it's just not the way to do it. And we should specify when we say service account, people will often make service accounts in Active Directory, for an example. That's still a user. That's not a service account. We just give it a name that it's used for a service.
Right.
So this is particular in the Kubernetes services. And it's just auditing, right? And I don't care where you work, but in highly regulated, even worse. You can't tell how somebody did or who did, you got problems.
Yep, absolutely. Because it's not if the bad thing happens, it's when the bad thing happens.
Or the accident happens. Right?
Or the accident, right? Like not everything is nefarious. There isn't always a, Cobra Commander might not be trying to hack you, but, George forgets to log out of his terminal and his kid hits a button.
Or you got the wrong context.
Or you got the wrong context. That's personally never happened to me.
Oh, never. Yeah, I
never.
can't say I know why that.
But I could see where that might happen to people.
Absolutely.
So you don't want to use service accounts. So now we're going to get into talking about understanding OpenID Connect. Now we get into a deep dive here. I'm not going to repeat it for the show, but OpenID Connect sits on, I think, about 200 RFCs. So that's a lot of RFCs you're going to go read if you're going to want to know how it really works.
So Mark, just for the people, I mean, I've been around IP a long time, so obviously you're RFC a lot just in that world. I mean, not just IP, but that's where I came from. What's an RFC? Why do we care?
So that's a good question. So RFC stands for Request for Comments. And it is the format that's used to publish IETF, Internet Engineering Task Force standards. So almost all the standards that we work with in the tech world, well, I would say probably the vast majority of them are published by the IETF in this request for comment format. They all have individual numbers. They're all confusing as hell. Like, even if you know what you're doing, they're confusing. So if you find that you're going through the RFC to figure out how to deploy something, you've probably taken a wrong turn, right? Like, there are dragons there. Unless you're an implementer like us and you're like, you're writing things to implement these specs, chances are you've taken a wrong turn. But the thing is that OIDC is made from so many different specs, and there are so many different ways to do it. And quite frankly, even like Kubernetes doesn't actually do OpenID Connect correctly. Like most people don't really understand that. But when you use OpenID Connect, you authenticate, you get two tokens, an ID token and an access token. The access token is supposed to be opaque. You're not really supposed to know what it is. It doesn't matter what it is. Your ID token is what we call a JWT, a JSON Web Token. So a bit of JSON digitally signed. That token is not for other things. That token is just for you as the client to know who the user is. Well, this thing is self-contained, right? It's got all the attributes about a user. They're called claims. It says who you are. It's got a begin and an end. It's digitally signed. I don't need to go back to an authorization server to validate it. So what developers have said is like, yeah, I'm just going to pass this thing around. It's not really the way it's supposed to work. It's the way people do it, but it's not the way it's supposed to work. And so it's one of those things that you look at and you're just like, okay, I guess we're gonna, we're gonna go with this. And my friends in the identity world are like, no, this is terrible. I'm like, too bad. That's the way people use it. So the nice thing about OpenID Connect is it includes everything, right? Your users, your groups, an expiration. It's got a way to refresh. Kube Control supports it natively. Applications support it natively. It's your best bet. Now, we're going to talk about this a little bit at the end once we start going through impersonation. But a lot of clusters will not let you do OpenID Connect because you need to have access to the API server configuration to be able to do that. As I even just an on-prem thing, like I think Tanzu doesn't let you do OpenID Connect. You have to either use their authentication system or is it still called Tanzu or have they renamed it?
In vSphere, it's Kubernetes on VMware now.
Oh, is that what it is? Okay, I wasn't sure if they had rebranded.
Yeah, they're trying to get away from that. I think the Tanzu branding a lot.
So sorry, anonymous LinkedIn user. We have no idea who you are.
Yeah, it doesn't come up.
So then you get, okay, well, how do I authenticate? Well, if you're using one of the hyperscalers, you can use their authentication. The problem I often find with any of the hyperscalers, this isn't just Amazon AWS or Google or Amazon Azure or Google, it's all of them, is their permission structure in Kubernetes RBAC don't really align super well. And so in order to get the right combination of permissions, what ends up happening is you end up over permissioning people. And that becomes a big concern because you don't want to least privilege, right? And so how do you avoid that? Well, you just take the hyperscaler out of the equation and use impersonation. We'll cover that when we get there too. The other important reason why you might not want to use the hyperscaler authentication is your cloud team doesn't want to deal with this, right? Like your cloud team's got enough on their plate. They don't want to deal with your access concerns either. So if you can now offload that to something else, it makes it a lot easier.
Well, and a lot of works right too, Mark. You're not a single cloud.
Right.
Most, especially in a highly regulated industry or global, right? We're going to use a couple different clouds, and everyone's different. So if you have the pleasure of developing across your on-prem and across 4 CSPs, you've got some things that have to change.
Yes.
Because of how things are accessed, unless you, of course, start dealing with what you'll be talking about throughout this. So
we've talked about OpenID Connect, and then we get into anti-patterns, and we say, look, here are the other options, don't use them. We talked about certificates, why you don't want to use certificate. We talked about the fact that you can't use a smart card to authenticate. And something else about certificates that's important is that you can use groups with certificates, but you've got to embed it into the cert. So now if your role changes, like your real world role, maybe you switch teams, maybe you whatever, you can't get taken out if you're using certificate authentication. That's permanent until it expires or you rekey, right? So that's another reason not to use certificates. Also, additionally, certificates don't give you access to applications. Kubernetes is more than your API, right? It's dashboards. It's, different systems. Your typical cluster might have a GitOps system, a monitoring dashboard, a logs dashboard, a Kubernetes. Those are all systems where, those are all systems that you're going to want to have access to. And having OpenID Connect, is a big part of being able to do that. And so Kafka makes the comment here. Keycloak as an IAM service and Kate's cluster provide SSO. Yeah, we're going to show something very similar today. In the book, we use Open Unison, but that is absolutely correct. That's the model that I'm a big fan of, because you want to give control to the people who own the infrastructure, not make your cloud team have to do it. So we talk about certificates. We get into service accounts. We already talked about why that's a bad thing. And this actually brings us to our first lab, where let me go ahead and bring us here. I'm good, right? Okay, cool. So anybody who's following at home, I'm on page 182. So the first thing we're going to do is we're going to create a service account. Now, starting with 1.24, secrets were no longer automatically created. So we're going to create a secret that is bound to this service account. Right, to get that right. Yep. Bad request. What did I do? Oh, you know why? Because it didn't. For some reason, and I don't know if it's the. I'll do it this way. It's for some reason it's the way that the copy and paste works out of these PDFs.
I've run into that a lot myself.
Unfortunately it doesn't keep the indenting. I don't really understand why. So let me fix this. Metadata annotation.
Yeah, your spacing, obviously, like you said, is all.
Yeah, I think that's okay. So I'm going to go ahead and create this. Let's try this again. clear. All right, so I created this secret. Oops, we'll get there eventually. And so now let's go ahead and take a look at what that secret looks like. So this is a secret for a service account that is bound, but it's not using the projection API, the token request API. So get secret. Let's see here. Am I looking at the right one? There is a secret, type opaque. Why did it not create? There's the annotations. Oh, nope. Did it to me again. K delete secret ISA. Yeah. ISA secret. All right, clear. Let's try this again. Once more with a little bit of feeling. This is not an annotation. It goes there. All right.
And this
now, there we go. Okay.
A big key point that Mark brings up to everybody watching is the fact that it doesn't do this automatically, right? So there are still some of these GitHub examples out there for certain add-ons that don't specify this. They still say create the service account, grab the token. You might go and go, there is no token. Well, no, there's not. You got to go create it as Mark is showing here. It's rare, but I actually ran into this Monday. So I'm looking at the GitHub.
Really?
Oh, yeah. Yeah, it's an old example, but still relevant. Everything else works except for that part.
So we show this off in the book, and I'm going to show it off here as well. So this is an example. This is jwt.io. This is a really super helpful website. Now, when you post things into this website, it does not go out. You can trace it. It doesn't go back to their servers. But be incredibly careful as to where you paste things, because these are bearer tokens. And, here's our issuer, but there are no dates here, right? This is good until I go ahead and I delete my account, or I delete the service account. So let's go ahead and use this in a actual API call. So first thing I'm going to do is let's come back here and clear it out. So I'm going to call the API and I'm going to come back and it's going to say forbidden, right? I'm system anonymous. We've disabled anonymous authentication, which you always want to have. So now
standard for the last 3 years now in most distros, right? So
yeah, I mean that's the standard now. So now we're going to use our service account token, and we're going to do hold on a second. I'm going to cheat a little bit. Export kube _az equals this. So this gets us our token. So if I do kubeaz, that's our bearer token. That's what we were just looking at inside of jwt.io. And now let's go ahead and run we're going to add a parameter to our curl command. In addition to our call, we're going to now add our bearer token. And we'll see that I get information back about the API, right? So I'm authenticated as a user using this token to the API server. And again, whenever we're talking about Kubernetes, we're always talking about an API, right? There is no application. There is no spoon. Everything is an API. So you have to think of it in those terms. So, don't use service accounts. Right, they're great for when you need to talk to the API server from a pod, or even, and we'll talk about this in later chapters, especially when we get to Vault, you need to talk to external services, but you don't use service accounts to access your cluster. They were never designed for that. It's an anti-pattern. One of the things that the Kube maintainers have done is to get away from that is implement what's called the token request API. So now, and this has been standard since 124, when you launch a pod, that pod has its own service account token, but it's short-lived. And so you can now generate a token that is as short-lived as, I think, 10 minutes. So that way you're not using, or you're not running into issues with the token being long-lived. And it's even bound to that pod. So if that pod dies and somebody takes that token and tries to do something with it, even if it hasn't expired yet, Kubernetes will reject it.
And there's
Right,
no,
so-
correct me if I'm wrong on here, Mark, but no secret created on there, right? It gets mounted just in
Correct.
a pod. Now, this brings up something I have to mention on here because I ran into a vendor with this at one point, and they said, here's my problem. It had extensive permissions. And they said, well, Scott, why does it matter, right? Nobody can get that secret. And I said, yeah, I can exec into the container and still get to where it's mounted.
Yep.
You can still get to it. They didn't even know this, right? I showed them. And then it took the token, issued API calls.
Yep.
And they said, oh, so this is kind of touchy because a lot of people do this. They'll say, well, it's a namespace service, but yet they bind it to a cluster role for something. And I'm like, this is my problem. Anybody who can get in there now has that token or can get that token. And I'm going to say impersonate, wrong word for it, but it kind of is because it's not impersonation, but you're using it.
Well,
So
it's credential theft.
Yes. Yep.
Yeah, no, that's a great point. And we'll get into this in later chapters. A big part of cluster security is, look, if you have a application that is insecure, right? Like you have an application that has a security vulnerability in it that is unpatched, and somebody exploits it to get into your cluster or into your pod, now that anything that's in that pod is now up for grabs, right? And so, if now the NSA released guidance, I think it was 2 years ago, on container security, and how to securely do containers. Now, forgetting the fact they totally glossed over authentication authorization. One of the things they say is don't enable service accounts for your pods, because you can disable service accounts in your pod. And there are times where you should do that. Like if you're never going to talk to the API server, you should totally disable that, because why put it there if you're not going to use it? But I think one of the things and one of the trends you're going to see more of is, with CRDs being as easy to implement as possible, you're going to start to see more and more where CRDs become the configuration mechanism of the data center. Now, there are projects, there's a project that's escaping me, that is just a Kubernetes API server without the Kubernetes API. So it's basically CRDs as a service that lets you do that, but you still need an identity. So I think that this is one of those things where it's fine for now, but you shouldn't hang your hat on it, because more and more applications are going to continue to use CRDs for their own internal use. And just turning off the identity is probably not really just going to get you all that far. So we're talking about token request API, and I'm trying to see here. Okay. So the nice thing about the token request API is it lets you request short-lived tokens. So here we're going to generate a token using kube control create token mysa and default. So this generates a short-lived token. So we're going to look at this inside of jwt.io. I'm going to kind of go back and forth between these two. So here's the token we dropped in. Now you're going to notice a big difference. So this is the one that is static. It's just information about the secret and the service account. There's no dates, there's no times, there's no expiration. Here, this is the one that was generated by the token request API. It expires in 1241. It expires 1241 GMT. So what time is it now, GMT? It's
4 hours ahead of us right now.
yeah, so I think that's what so this was created on, oh no, okay. So this is good for 1 hour, right? It was initiated at 1241 and it
Yes.
will expire in an hour. That's still a long time. You can do a lot of damage with that. So you can cut it down. But the point is that it's only good for an hour. Also point out that this service account is bound to or this token is bound to the service account. Now, if we'd gotten this out of a pod, there would be information about the UUID for the pod would be in here. So if that pod went away, even though this token hadn't expired, you can't use it anymore.
Yep.
So that's important. So now we're going to do our same kind of lab exercise we did before, right? So here we called it with nothing, and we got forbidden, right? So we're going to use the same tactic we did before, but export KubeAZ. So we got a new token, and we're going to call that curl command with the bearer token, and it works, right? So now we're actually getting a token in a way that is not permanent. Now, this doesn't solve our service account from the outside world problem, but it at least makes it a easier to manage issue, right? Because you don't have any like you don't have that permanency. So now David asks a great question: what scope of permissions does that short-lived bearer token inherit? Whatever the service account is allowed to do, right? That token is a representation of the service account. So next week we're going to get into RBAC and we're going to talk about that. But if that service account token, if that service account that represents is a cluster admin, then the token is a cluster admin. If it's a and that's all based on RBAC. What you can't do is generate a token that has groups in it. That would be a little interesting. But as of right now, the Kubernetes API doesn't let you do it. So that's a great question. Thank you.
So bindings, right, Mark, as we want to get into in this case, is no different from a user in that respect, unless you talk about system stuff. Let's not, we'll talk about that in our back. But yeah, I think people tend to look sometimes at service accounts and go, oh, they must have higher. It's like, no, not necessarily. It depends. But
yeah, exactly. So then we talk about custom authentication webhooks. And like I said, don't do them. Like if you're writing your own custom authentication webhook and you don't work at AWS or Microsoft or, any of these other companies that have built-in cloud authentication, systems, you're doing it wrong. Like, I'm a big, you might not be able to tell this about me. I'm a big Star Wars fan. I'm a bit, it might be hard to know this. I don't talk about it. I am a big Star Wars fan. And when they say only the Sith deal with absolutes, in this instance, you're absolutely wrong. If you're like, I might be making people mad, and I am sorry about that, but if you're writing your own authentication, you're doing it wrong. So we don't talk about how to do it in this chapter. So those are the different approaches to authentication for the most part. Now, we're going to talk about how to actually enable OpenID Connect in kind. And, going back to chapter 2, when we talked about why we chose kind instead of other options, this was a big reason, because kind is basically kubeadm in a trench coat. Although, dirty little secret about Kubernetes is almost all the commercial vendors are kubeadm in a trench coat. But, so we can actually go ahead and run OIDC in there. Yeah,
Well,
I've
and
become a
especially back in the first edition, right, Mark? I mean, Kind did it where other little distributions had nuances, I want to
yeah,
say, with OIDC. So once we started using it, we kind of kept it as well.
yeah.
Um, yeah,
And so we're going to talk about, what is probably, and I still see this a lot, integrating LDAP and Active Directory into, into Kubernetes. Um, in the enterprise world, you have Active Directory, whether you like it or not. You have it. So, excuse me. The issue becomes that you have to know how to live with it. You have to know how to use it. And so Kubernetes doesn't know how to talk LDAP. Like there are some custom webhooks that try to do like pass the password with LDAP, and they're all horrible. So we're going to look at how we do it with Active Directory.
and I know this
And
topic,
we're
Mark, it's really big, and like always, we like to expand on things, but I think the lab for installing it, to me, is a great thing to show, because I get this from a lot of people. People that read the book, people internally in my company that I say, oh yeah, I'm doing this at home and I want OIDC, right? So I tell them, go to the Git, grab this. I know in the past, Mark has been always very, very polite about my scripts and how he uses them. I do the same on this chapter for everybody, right? Because you don't need authentication in a home cluster to play, but you should, right? You don't want to play with that. I'm going to call it the break glass kube config, right? You should be doing what you do in real life. That's how you learn. That's how you learn these topics.
exactly.
So I enable all of this. You don't need AD, because Mark's been gracious enough to give us Apache DS in this, right? So it looks like AD, but it's a great script.
Well, thank you. And you make an excellent point about home labbing. One of these days we're gonna do a little excursion. We're gonna take a break from the chapters of the book, and we're gonna dive into home labbing, because especially in today's market where jobs just aren't as easy to come by as they once were, and you really need to show a differentiation. You need to show that you know your stuff. As an interviewer, seeing that you've got some kind of home lab setup is kind of a good thing to see. And I will tell you that I've gotten to the point where I can access almost everything in my home lab using my GitHub credential, right? Because like I didn't want to deploy a directory in my home lab, but I have GitHub off, so that makes it easy for me. And so we'll dive into that one day. But I very much appreciate that, Scott. That's high praise. So we're going to dive into this, and again, we're going to do RBAC next week. We're going to map our Active Directory groups into Kubernetes using RBAC bindings. Kubernetes doesn't really care if it's an Active Directory, OIDC. It doesn't matter. It's just all streams. Now, one of the things that we did this in the second edition, we included the Active Directory. And the reason why we did that was the first edition of the book, we actually built a testing identity provider, and we put it on the Tremolo security website. And we had gotten feedback that like, hey, I don't want to have to sign up for this company Tremolo just to use the book. And I got that. Like, even though it's free, like, and we never spammed anybody. I get it, right? Like I'm a security guy. I've got a few tinfoil hats that I'll wear. I don't like signing up for things either, even if it's free. So we said, okay, let's go ahead and instead do this via the built-in Active Directory. And some of the things to think about when you're talking through how you want to access your cluster is you want to make sure you have short-lived tokens, right? The setup that we're going to do here defaults to 1 minute. So, why is it so important to have short-lived tokens? They're bearer tokens, which means that, back in the day before we had electronic tickets to everything, you'd go to the box office for your favorite sporting event, right? They'd hand you a ticket. That ticket didn't have your name on it. Didn't have anything that ID'd you. All it had was ticket information. So if somebody snatched them out of your hands, ran through the turnstile, you got nothing, right? You're not going to the game. Bearer tokens are the same way. Like there have been attempts to try to do things like bind a bearer token to a TLS connection. They have failed miserably because of the impact on of proxies and scalability. There is a very interesting spec that it's been used by S3 for years. It's called HTTP signatures. And the interesting thing about HTTP signatures is, unlike typical bearer tokens, it can survive movement through multiple reverse proxies. Unlike TLS termination or TLS authentication with certificates, it can survive multiple reverse proxies. Now, the major downside to that is it becomes difficult to include identity data in there. So you've got to know who you're talking about. So it's a give and take. But that's a great standard that's making its way through. I expect at some point we'll see that being supported by Kubernetes. But that being said, you want your tokens to be short-lived because anything can log a token, right? Like, who among us hasn't accidentally checked the token into GitHub? I mean, I personally haven't in like the last day. But it happens. Like it happens so often. They actually have a service, right, that's solely focused on that. So you want those tokens to be short-lived because anything along the line, even something as simple as an errant debug statement, can become a way to lose that token. So you want them to be short-lived. You want to include all your groups. You want them to be constantly refreshing. You want to manage your permissions with groups because, one, it keeps your RBAC simpler, right? It makes it easier to maintain that. And two, it becomes easier to audit because now instead of having to you can't search Kubernetes and say, give me all the users, all the groups this user is a member of. You have to enumerate every single RBAC binding to figure that out. And you don't want to do that if you don't have to. And then we're going to do dashboard access. Now, we have an entire chapter dedicated to the dashboards. We're not going to get too much into the details. Just know that at this point, we're deploying the dashboard securely. So
probably no
I'm
time to get into
ahead.
those details, Mark. You got 6 minutes.
Yeah, exactly. What we might do is we might do OpenID Connect this time, and maybe we'll do another one next week to do impersonation and pipeline authentication. So I've already deployed my cluster. And so I'm going to go ahead and let's deploy.
And that's just a standard cluster from chapter 2, right, Mark?
Yes. So that's just the standard chapter or standard cluster. We haven't done anything special to it. And we're going to go into user auth. And we're going to do deploy OpenUnison impersonation, no impersonation. All right. So what's the script doing? It is creating our Apache DS, which is going to be our Active Directory, using my quotey fingers, because Apache DS is obviously not Active Directory, but running Active Directory, you can run Windows in a container. I guess in theory you could run Active Directory in a container.
You could, but man,
Maybe.
Setting it up and you're gonna,
you don't want to do it.
You're also running in core mode, so you better know all your PowerShell.
Yeah, I probably don't want to do it.
This is perfect because adding a user, edit the config map. If you want to add.
Yeah, so that's the thing. So this directory has a config map. So if you want to use this for more than just this lab, there's a config map in there that just does the thing.
Not production. It is a config map with a password. So,
right. So you don't want to do that in real life.
It's perfect for testing.
Exactly. So we've gone ahead. We've set up Apache DS. Now we've rolled out the Kubernetes dashboard. Now this does use Kubernetes dashboard 7, and we'll get into that in a few weeks. But dashboard went through a lot of changes in 7. So now we're deploying OpenUnison. I didn't want this chapter to become a chapter on how to deploy OpenUnison, so we kind of just did it. It's in the script. There are plenty of instructions on how to deploy it. Excuse me.
And there are other alternatives, as you know, like Kafka, you kind of brought up yourself with Keycloak, Dex.
Right.
And this is where I always kind of get involved because it's easy for Mark to say, right, use OpenUnison. His company is, well, that's them, right? But I always have to point this out that I'm the one that when I was first approached, I was approached to write a book, and I said, you know what, that's a lot of work. I have a person I think I'd like to partner with on this. And there were a lot of reasons for that. I forget just the knowledge, the fact of different worlds, Mark development, myself coming from a lot of background on networking, you know, distributed compute. But I was introduced to Mark through OpenUnison because I wanted to use it. And yes, you can pick other things for OIDC. That's one way, first of all, to get support for those, right? We're talking enterprise. Dex, you're not getting support. Keycloak, you might on OpenShift. That's it. So you might want to support it. Not just that, though. We're using one version of OpenUnison here, which is the, and correct me if I'm wrong, Mark, you can call it login portal, for lack of a better term. There's another, I'm going to say version, still open source, but you get workflow management, and you can do a lot with it. So I want to make sure, I kind of call it out, and I'm sure people are going to say, well, that's because you like Mark, blah, blah, blah. Okay, yeah, but there's reasons for this, right? It didn't start there. What you see Mark and I as our back and forth and how we communicate with each other started as a vendor kind of like client discussion. It kind of went from there, like Star Wars, Marvel, science fiction. That kind of got into it too. But especially back in the day when we met each other, we weren't a lot of people in Kubernetes that I could find in 7 years ago. So there's a common bonding of the geekness. So everything that Mark will show here, as we're getting into this, yes, you can do this with some other things. Except maybe when we get to like the reverse proxies and that, right, Mark? Not quite as easy, but
right.
Cool, and it's deployed. So I wasted enough time to get to the deploy part.
Yeah, no, that was great, Scott, and much appreciated. So we're gonna go ahead and log in, and I'll close that off. And we're gonna get presented with, first off, we'll go skip the certificate, right? I'm gonna make this a little bit bigger so it's easier to see. So we now have the login screen. Now, the important thing to understand about Kubernetes login and OpenID Connect, OpenID Connect doesn't care how you authenticate. It is not an authentication protocol. So it doesn't care if it's a username and password, if it doesn't care if it's a certificate, a token of some kind, it just, Kerberos, it doesn't care. All it cares is to say, you have authenticated, and now I'm going to tell somebody that you authenticated. And so we're going to authenticate to OpenUnison. This gives us kind of that entry point into Kubernetes. Except that's not password, that's password. So we're authenticating against our Active Directory. And you'll see here that we've got two badges, tokens and the dashboard. So I'm going to go ahead and go straight into the dashboard. And we're going to notice that it's just kind of stuck in a spinny state. Well, after we get through this part. Right. So what's happening here is the dashboard can't authenticate. Right. It doesn't know who I am. Because the way the dashboard works is dashboard takes my token, which is provided by OpenUnison as a reverse proxy. And we'll get into this when we get into the dashboard chapter, and forwards it onto the API server. The API server gets this token. It's like, I don't know what this is. What do you want me to do with this? We're going to take a more direct example. So I'm going to grab my token here. This is the token screen for OpenUnison. This is what gives me the ability to log in. I'm going to come over here, and I'm going to go ahead and create a new tab. I'm going to make this bigger. Now, as you're doing these labs, make sure don't do it on the same context as your kind, because your kind has a master certificate. So I'm going to create an export kubeconfig. So this is my favorite way to do this, where you create a temporary file, and bam, your Kubernetes context is now set. So I'm going to say k get node. Like it has no idea what's going on here. Connection refused. Did I do this right? Hold on. Is there a problem with the way this is set up? Because this is actually not correct. It should be interesting. Kube control. Oh, I think I grabbed the Windows command by accident. Let's try this. Okay, get no. Interesting. Oh, here we go. Unable to connect this. Fail to refresh.
Yeah,
What is going?
Is that should be it's a normal error, isn't it, Mark? Because at this point,
Okay.
it can't authenticate the token.
Right. K, who am I? K.
Which we should probably say in this, everybody's watching this, that we don't necessarily expect that to work yet.
Right. It shouldn't work.
Yeah.
And the reasons for that. Here we go. Cannot fetch token. Unauthorized. That's what I actually expect.
401 should be normal. I think it's that I see where you're getting a little bit thrown off with that error.
Yeah.
But this is expected, is what I'm going to say for us. Well, because we're not fully configured at this point.
Right. So what we're going to go ahead and do is let's configure our kind cluster. So that way.
And for anybody kind of sticking around, we're going a little bit over. Won't be too long.
We're going to go a little bit over today.
A very important part.
Yeah. So I'm now back in my I'm right now back in my SSH. Oops. And I'm going to go to clean this up a little bit. So first thing I need to do is I need to get a certificate. Right. So this gets the certificate for Open Unison because we need to get our cluster. ouca.pem. So this is the certificate for Open Unison because Open Unison is the identity provider. We need Kubernetes to trust it. So now here's the thing that is a little bit interesting is because we're running kind, and kind, of course, is running in Docker. So what we need to do is we need to copy the certificate into our kind cluster. So we're going to copy it into the control plane. And so now it's running inside. So this is not something obviously you do in production, but I really hope you're not running kind in production either. So as part of the installation, we generate the API server config for you. So we create a config.
This is in page 191 for anybody who happens to be looking at the book. So what Tremolo's done, and Mark in this case for this is probably what we should have said before we got into this is you got to edit the API server options to tell it how to handle these. Like who do I go check to make sure that this token is valid? And that's where we get these commands from, which is great because not everybody knows these, right? If you read the Kubernetes documentation, it just says fill something in here, right? Fill this in. And this is just all kind of provided. And that's where that certificate, as Mark was saying, it is used because it needs to do that, right? To verify this.
Yep. And so I took these and I just put them on a text pad off screen here because now I actually have to go into my pod. Into my container, and there's no text editor in here. So we're going to go ahead and update so that we have our packages, and then we're going to install Vim or whatever your favorite text editor is. I'm old-fashioned. I know how to enter and exit Vim, so I'm going to go with that. And then we're going to edit our Kubernetes API server manifest. So here's the Kube API server. Now, if you are familiar with the latest news in the Kubernetes world, starting with I think it's going to be in 33. It's either 33 or 34. It'll go GA, I think. Structured authentication is a new way to do Kubernetes authentication, where instead of being limited to a single issuer, the way Kubernetes prior to that is, you have multiple issuers, and that becomes a really big deal. We don't talk about it in the book because when it came out in the book, it was still in alpha, which means there was still a lot of changes that could happen. Once it gets to beta, the APIs are pretty stable. They don't go through a lot of changes. But alpha, they're still pretty volatile. So we decided not to include it in the book. But maybe next week we'll still end up doing that. So what I'm going to do is I'm going to take the configuration options that I saved here off screen from that config map. And I'm just going to go ahead and paste these in.
And these options for everybody would be the same in any kind of flavor. It's just a matter of how you add them will change. Like in a pure kubeadm node, you would edit the manifest under the etc Kubernetes, I think, manifest directory, right? You'll see API server.yaml, which is essentially what this is doing behind the scenes, right, Mark? With and then it'll restart the kind.
Yeah. So what's going to happen is this file, when it changes, the static pod that is the Kube API server is going to say, "Oh, this has changed. Let's go ahead and restart." And what we're telling it here is we're going to give it the issuer. So this is what's called a discovery document. And this has all of the URL endpoints. It's got all the certificates, everything the API server needs to validate tokens.
And this would be from the RFC spec. Correct me if I'm wrong, Mark.
Yes. This is one of the RFCs. A client ID. So this is what is who the token is issued to. Now we keep it here generic Kubernetes, but could always change that. The username claim. So all the attributes that we showed you before, those are called claims. So sub is typically the claim for your user identity.
Kind of depending on the structure and
yeah, it's unfortunate. A lot of times people want to use email address. Please don't. I beg you, don't. The problem with using an email address is email addresses are typically based on your name, and names change for a lot of reasons. So you want to have something that is immutable, something that won't change. A lot of corporate identities give you a number, or a randomly generated short string. But the point is don't use a human name as a computer identifier, because those will change. And the groups, where the group's coming from, and then finally the certificate, so we'll trust it. So let's go ahead and save this. And I'm going to exit. So I've left the context or the container for the control plane, and I still have my my kind context here. So we see that it's kind of taking a quick second, right? And that's because the API server saw that change.
Right, Mark, if you do a
right, but the API server is running inside of Docker. So
that's right. You're not going to see
you won't see anything. I'm a little surprised that it hasn't come back up yet. I wonder. Oh, here we go. So cannot list pods. So that's probably, here we go. All right. So you can see our Kube API server is coming back to life, right? So now it's running again. So it takes a hot second, but the API server is restarted. So now let's see if this magically works. No, it's still not working. I don't KCTX. All right, let's focus instead on, let's come back here. And if we go to our dashboard, let's give it a quick refresh. And we can see now that I'm not allowed to see anything. I'm going to make this bigger.
Very different from not knowing who you are.
Right. Now it's just not letting me do anything. So let's go ahead and so we verified I'm now on page 193, and we can see that it knows who I am. It just doesn't want to let me do anything. So we're going to create a role binding. And this is going to be a little interesting. I'll have to clean this up. Oops, that's not a V. That's a V. All right. So, subject, kind, role ref. That's actually okay. It's a little bit of a weird set. Oh, that's why. That has to go there. All right. So we're going to create this role binding. Now, if we come back here to Open Unison, we'll see that I'm a member of two groups, Kate's Cluster Admins and Group 2. Don't worry about Cluster Ad or Group 2 for now. So what we're going to do is we're going to come back here. We're going to create this role binding, which what did I miss here? Did I forget to actually copy this? No, this is.
Oh, I've had this in the book. Mark, look underneath your role ref.
Yeah.
194, integrating authentication into your cluster.
I swear, I just fixed this. All right, metadata, subject.
The copy and paste in the book has bitten me more than once.
Yeah. Role ref.
I should say from the book, from the PDF.
Yeah, the PDF. All right, let's try this again. All right, so this time it got created. And what we did was we created a reference to the group that I'm a member of, coming from AD, as a cluster admin. Again, we'll get into this a little deeper next week when we get, or 2 weeks, I guess, when we get into chapter 7. So now there are no more errors, and I can do whatever I want, right? Like I can, I'm a cluster admin, so now I have access to everything inside the dashboard. Now let's see here if this fixes this particular problem. I'm going to try logging out and logging back in. Typed in the wrong password. So I'm going to go Kubernetes token, and I'm going to run.
And drum roll. It should work, but
yeah, things have been going a little weird here. So I've removed it, right? Get nodes, nothing, right? It has no idea who I am. All right, so now cat kubeconfig. So it's got my IDP issuer in there, right? It's got, why does it have my local server in there?
I've actually seen this in something. It just came up last week from somebody internally that was playing at home. Mark with that.
That is strange. Why does it have?
That is a value in the Helm values.
Yeah, it is.
And somehow it wasn't putting in the API server. Now, if you edited that manually, I did have mine work. But I, changed that server too.
Let's see here. So is this a bug in the? Oh yeah, must be a bug in the script. All right. 192.168.253. Yep. Interesting. I wonder if that is that must be a bug in the generation script.
Yeah,
it's coming up with 0.0.
That easy, but
yeah, that's an easy one to fix. But okay, let's go ahead, and that's how you know there's a live script, live show. Everybody, something went wrong.
On this, Mark, why don't you just edit your config and?
Yeah, that's a good idea, just to make life easy.
Yeah. So everybody in here, that's being used to build the command for group control. That's putting in the the API server location, right? So that's why you're getting 0 on this. It obviously can't connect. When you do 0.0.0, it's saying listen on everything. It doesn't let you connect to that.
Exactly. Was it token? And Open Unison. So this is how you configure Open Unison. Everything's a CRD. So there's no GUI.
Makes it very
Let's
extensible.
see here.
We're doing a lot of stuff.
So this is all Kate's cluster name. Can I edit it directly in here? I might need to.
I just edited my config file, my kube config to do something. Of course, that'll change if I have to copy and paste it again, but.
Right. Trying to think, why is this CA cert name, cluster name, servers Kate's URL. Oh, it is hard coded in there. That is weird.
Yeah, you could just change that.
All
right for the.
It's going to end up redeploying anyway, so I'm just going to run OU control. OU control or temp. OU control install auth portal. Temp open UC values. So we'll just go ahead and let that rerun. This will take just a moment. So, and that'll fix the issue that we're seeing.
And it's not a configuration file for like the API server or anything for everybody watching. It's just the kube config doesn't know where the API server is because of the command being built.
Yeah, I'm really annoyed because is that like a copy and paste issue, or because I'm looking at the no impersonation code.
That's what I was just doing.
Oh, I see what happened. I must have done this at some point where I hard coded it to 0.0.0. All right, I'm going to fix that right now. That's the problem.
I'll give you a name.
I'll fix that.
So one of my friends, Pradeep, had this issue last week. Mark, I meant to mention this to you. We just fixed it manually.
Yeah. But yeah, so we're just redeploying Open Unison here just to make it nice and quick. Okay, so now we're good. All right. Joys of live television, right, folks? So I'm going to close this. I'm going to log back in again. Oops. A little too quick. I'm going to grab a token. Come back here. RM kube config. So we're going to start fresh. Kube control auth. Who am I? I'm really just not having a good day. Certificate is valid for. Oh, because I didn't include the cert from the Kube API cert. What? My script is going a little squirrely today. So here's what we're going to do. We're going to go back to this. Oh, I remember. This is never going to work from a remote. This was never going to work from a remote console. That's why this isn't working. That's why I have this hard coded to 0.0.0. Okay, so here was the problem. When we deploy kind certificate has a certain set of a config for what the certificate that it generates should have as a name. And when we use that with when we deployed it, it doesn't have the IP address that we're running on included. So it can't be used. So we have to access the Kube API locally. So that's why this isn't working. So the script was actually right the first time. I'm doing this right. Yep. Okay. So we just have to do it locally. So, okay. Everybody bear with me for a second. I'm going to go ahead and fix this and redeploy. So it's working right the first time.
We're a little bit over that we planned.
Yeah, but that's okay because people hopefully are learning how to debug their Kubernetes. So what we're going to do is we're going to access it locally from our testing VM. You cannot access your cluster remotely using OIDC with Kind because of the way that Kind is set up.
You could, right, Mark? We did start dealing with certs and.
Well, you would have to
Yeah.
pre-set up Kind with the right
Yeah.
IP in the cert. And I think we thought about doing that, and it turns out that's actually a lot harder to do than we originally anticipated. So next week when we do impersonation, we'll actually be able to access the cluster remotely from our from anywhere in our network versus this where we're going to have to do it locally. But the nice thing is that after this, all of our examples actually use impersonation. So that way you're not stuck locally. So, okay. So I have our kube control, get nodes. So that's that. And then auth, who am I? So fun fact, the first issue I ever opened on Kubernetes was as I was first working with Kubernetes and writing the documentation for Kubernetes OIDC. I was having a problem trying to figure out who I was and if authentication worked. I said, there should be a who am I service. And that was the first issue I ever opened in 2016, I think, early 2016. And I was told that wasn't possible at the time. They were blaming Google. Like there was something with the way Google worked and GKE worked. And so in 30, I think, they actually implemented. Somebody came around and was like, no, this is way past due. So we can see now that I am kube admin. So I'm going to do export kube config gets make temp. Right. So echo kube config. Yep. And so I have no context, right? Get node or auth. Who am I? Right. Wait, no. Export kube. Oh. Spelling matters, kids. Right. So now there's no connection, right? Because I have no config. So let's do this again the way it's meant to. I'm going to go ahead and refresh. It's going to ask me to authenticate. All right. So now I'm going to grab my kube control command. Okay. Kube control auth. Who am I? There we go. So now it can see that I'm logged in. Now, this is an important part of OpenID Connect. And this is one of the reasons why I'm a little hesitant to use OpenID Connect in the real world. Because or at least to use RBAC bindings directly with OpenID Connect in the real world, is because your username is a combination of your identity provider and your sub. Right? Like this is not your sub that's coming out of the token. The only thing that's coming out of the token is the sum mostly. But the original intent was always for Kubernetes to support multiple identity providers. Now, with structured authentication, that's a real thing. But that means that you don't want a user from one identity provider to be able to assume the identity of another identity provider's user because they might have different contacts. So it is super important to divvy that up, which means, let's say you start off with Azure and then you move to Okta. You've got to go back and redo all your RBAC bindings, which is why groups are better when it comes to your authorizations with RBAC. We'll talk about that next in a couple of weeks.
So I know this suggestion, Mark, is going to be a bad one from a security hat, but I'm going to mention them. The area you just had before, you could have done a skip TLS verify, right? Because I think that'll actually even bypass the IP.
I don't think modern versions of kube control even work with skip TLS.
Oh, it's been a while since I tried.
Yeah, I think that's one of those things that they're like, nah, we're not gonna let you skip this anymore.
Yeah, I'm curious. I'm gonna check while we're.
So we've got our kube control config. that's been set up, and we've done an auth to MI, and that is only good as of 1.30. So if you're on an older version, you'll run into, I think 32 is the latest, right?
32.2, I want to say, but
right. And we've already done the unauthorized. And so this is the part that I actually like to show off a little bit. So, we talked about short-lived tokens, kube control, get node, right? What's happening here is, I'm going to go ahead and let that run. Every minute or so, we're getting a new identity. These identities are only good for a minute, so it's just constantly refreshing. But if we go to Open Unison and now we say, let's log out, what will happen here is within about a minute, the refresh token that's used to refresh this context is going to expire, and I'm going to be signed out. So now if you think about this from security implications, this is a big deal, because you want to be, let's say I'm terminated. I need to get walked out. Somebody realizes that I lost a credential, and you want to terminate everything. And there you can see it's broken now. I can't authenticate anymore. The refresh token gets invalidated, and now I can get logged out, which is something that you can't do with certificates. And if you have a long-lived OIDC token, like even like an hour long, there's no way to tell the API server, just don't trust this anymore. So that's why short-lived tokens are so important. And that's only something you get with Open Unison, at least in the way that it's built here. The other nice thing about that is, about this setup is, the integration is all automated, right? So there's no, we had to set it up with OIDC, but other than that, it all just worked. Now, we already looked at the dashboard. We'll get into the security of the dashboard. If you're screaming the dashboard's insecure, no, it's not. We'll talk about that. Yeah. So yeah, we've kind of gone through that full circle of setting everything up. We're only about halfway through the labs, to be honest. We've got impersonation.
No, it's good to know.
For cloud managed clusters. So we'll talk about that one next time. And then we get into pipelines and how pipelines need to authenticate. So I think that will be a good place to go for next week. So I think we'll extend chapter 6 another week, so that way we can do impersonation and pipeline authentication.
A quick note, Mark. I did try the dash and secure skip. It's not in the help anymore that I can see, but it accepts the command.
Interesting. Okay.
So I'll have to see if it actually works. But if you do a wrong and incorrect dash option, it'll tell you. It's not barking at me. So, but it used to be right in dash help.
Yeah.
I don't see it in the dash help anymore.
Interesting.
But it accepts it at least. And I'm horrible to encourage it. Don't get me wrong. But for this case at home, labs, as much as I like to make them as real world as possible, there are certain shortcuts sometimes that I do need. So it's not something you want to tell somebody at work typically. Just type this in.
Yeah. That's bad. So thank you everybody for sticking around. We went a little bit over our usual hour, but we'll dive right into it next time. And as always, Scott, thank you so much for taking the time. Everybody who came to join, thank you. And if you've purchased the book, please take a moment, leave a review on Amazon. It makes a really big difference. I cannot emphasize this as much, how big of a difference a review makes in helping to spread the word. So anyways, thank you everybody for showing up. Thank you, Scott. And
thank you.
Same bat time, same bat channel next week, more authentication.
Thanks everybody for showing up.